Okay. So business critical, AWS and Asia Pacific Singapore. Once you click on get started, you will get an email link to your email. Just click on the link. It will ask for username and password. Once you complete that, you are good to log in into Snowflake. I already have the Snowflake account, so I'm not signing up again. I think it got expired today. All right. 1 second, please. Let me see if I have any other accounts. Okay, even I'll sign up. My account got expired. It should have.
Yeah.
I think I recently signed up. I remember it. Okay. Yeah, I think I need to sign up. Just a minute. Okay. All right. I'm selecting this both. Clicking on it. Clicking on get started. Skip. Skip. You can skip all this. You can see account setup in progress. Okay. So the sign up is done. So we will get a link to our email. Just click on this link. Then it will ask for username and password. So username, password, get started. Skip, just click on skip. Select, yeah, if you prefer dark mode, you can select dark mode, light. Right, you can see this is dark mode, system. Just select the system and leave it. Yeah. I just logged into Snowflake. You can see Snowflake is working. Okay. So before getting into this, so let's understand different types of Snowflake editions. So I'll start with architecture. Maybe let's get started with architecture, Snowflake architecture. So there are 3 layers. So what is architecture in general? For example, if you take your laptop, it has CPU, RAM, and storage, right? That is your laptop, like configuration or something. So Snowflake also. So for example, you can technically download Oracle to your laptop and you can install Oracle or MySQL database in your laptop. So what Oracle will do, suppose if you install Oracle, you upload any data. If you insert any data into Oracle tables, where the data will store? Data will store into your laptop hard disk, right? And also when you execute any queries, it will use the computing, the CPU of your laptop. It will do that, it will execute that query and it will show you the result, right? Let's understand in the same way. Okay, if Oracle is running on your system, so you will know the process, what it is doing. So in this architecture, we'll understand how Snowflake is running. You will get an understanding what is Snowflake architecture, how it is running on the cloud. So there are 3 layers. 3 layers. You can see 3 boxes, right? These are like 3 layers in Snowflake. So the first layer, you can see they're calling it as a cloud service layer. And also they'll call it as a brain of Snowflake. It is an interview, certification question also. What is like, which layer is the brain of Snowflake? That is one of the certification question they will ask. So this first layer cloud service is called brain of Snowflake, but yeah, the layer name is cloud service layer. So this cloud service layer is responsible for a few functionalities. For example, authentication and access control. I just logged into Snowflake, right? I just signed up and I logged in with my username and password. Then this layer is responsible for validating my username and password and provide me the authentication. So if I'm logging into Snowflake, we should enter the correct details, right? So once you enter, this layer is responsible for signing in. And also you can see security. So what security? So let's assume there is a database called HR database and finance database. Okay, so in Snowflake, we have two databases, HR and finance. So one of you working for HR department and one is working for finance. Okay. Now, HR shouldn't have access to this, and also whoever working in finance, they don't have access to HR, right? So you cannot access everything based on your privileges and all. You will be able to access only particular data, not the entire data in Snowflake. So based on your login, based on your credentials, and also based on the role they assign, this layer is again will take care of all those security and all. And also optimizer. What is optimizer in general? Like take any database, Oracle, SQL Server, or like Spark. Each and every this database has the optimizer. What is the responsible of optimizer is it will prepare the query execution plan. So what is meant by query execution plan? So for example, your query is this, like, you have written like select star from sales table. Uh, and also you will join with maybe country table on something like, let's give it like a S sales and this is like a C. S dot ID is equal to C dot ID. And now I also have some where condition, or like I'll do some joins like C S dot ID uh, is equal to 100, something like this. Okay, now what happens? Which condition needs to be executed first? So first, should it execute this AND condition or from condition? Which condition needs to be executed? So that is decided by query execution plan. So optimizer, what it will do is it will prepare a query execution plan. So query execution plan will prepare, okay, first execute the from condition. So what it will do, first it will query the sales table, and what it will do, it will query the country table. Then it will do the join. After joining, while joining, it will make sure that AND condition is also met. So something like this, it will prepare some query execution plan. Step 1, step 2, step 3. So each and every database, it has its own optimizer center. But yeah, Snowflake optimizer, what I heard is this is little advanced comparing to other optimizer. That means the way it will create plan will be efficient, and also maybe you will get results little faster comparing to other database. Infrastructure manager, yeah, we'll talk about this bit later. Yeah, infrastructure is nothing but like, again, this layer is responsible for managing the compute layer and storage layer. And also metadata storage. So what is this metadata storage? If you create any database name, if you create any database table, column names, column data types, all those details will be stored in the metadata storage layer. So we'll deep dive. That's not all. There are a lot of other features is there in cloud service. But yeah, as we move into the new topics, we'll come back to this slide and we'll talk about throughout the entire training. So for now, at high level, just remember like this is the first layer in Snowflake, and this layer is responsible for authentication and access control, and also it has optimizer, and also all the any table you create in Snowflake, the table details will be stored in the metadata storage layer. Any questions so far? If I'm going little fast, let me know. I can slow, maybe I can talk little slowly and explain Okay, so are you good with the explanation or you have any questions?
It is good.
Okay, you are good. Okay. And the second layer, yeah, don't get confused with the term warehouse. It has nothing to do with data warehousing. Okay, so yeah, they just named it as a virtual warehouse. Yeah, this is little confusing for very beginning. Most of the people will get confused. ఎందుకంటే like if you compare this with data warehousing concept, you will get confused. So ఇప్పుడు మన ల్యాప్టాప్స్ లో CPU ఉంటుంది కదా. What is the role of that CPU? To process, right? Compute, like to do the calculations or anything, to process or anything, we need that CPU. So Snowflake లో ఏంటంటే the second layer, it acts as a compute layer. So the name of this layer is called compute layer. So, and the third one is storage. So how exactly this will work, I'll tell you. So maybe let's see this. We have total, I'll give one example how these layers work. So the first one is called cloud service layer. Second is compute. Third one is storage. Okay, so for example, you created some table called sales table. Create table sales. Okay, in this I have ID and also maybe sales amount, or like I'll just put as a amount also integer or float. Yeah, just two columns for now. This is my syntax. Now if I run, yeah, sorry for typo, but yeah, if I execute this query in Snowflake, what will happen
Sir,
is,
just a minute. Can you please increase the font size? It is very small.
okay, yeah, I'll do that for next time. Yeah, so
Yeah.
all right. So now if I execute this particular uh, query in Snowflake, what will happen is Snowflake will create this table metadata in this layer. So you can, so are you able to see this metadata storage? So what happens is any metadata. So this is a metadata, right? What is metadata? Data about data. That is called metadata. So when you execute this query, this table will get created in the cloud service layer. Okay, here the table details are stored here. Now what happens? Let's assume you inserted some data. Okay. So for example, the client shared some sales data in Excel file. So that Excel file you loaded into table. How we'll load, we'll discuss in coming class. But for let's assume I loaded some data. So client sent me one CSV file. I loaded that file into this table. Okay, so any data we upload into Snowflake tables, that particular data will be stored in the storage layer. So the last layer you are seeing on Snowflake, so this is the storage layer. So the data will store here. So yeah, how it will store the data, in which format? Is it columnar or non-columnar? What is columnar? What is like, row-based? We'll discuss. There is one dedicated 1 hour session just to understand this topics. We'll discuss it then. But for now, as we are discussing about architecture at high level, just remember it like, okay, so there is a storage layer and any data we upload into Snowflake will be stored in the storage layer. So this is storage layer. And this is virtual warehouse layer, or we'll call this as a compute layer. So this is cloud service layer. Okay. Now, okay, now I created a table. I inserted some data into this particular table. Now I'm running, I want to run one query. So my query is simple, select star from sales. Okay, this is my query. Okay, whenever I execute this query, so for example, now we have Snowflake database, right? Like, let me log in. Did I close my Snowflake tab? Okay, here it is. I'll explain the navigation in a bit, but for now, just ignore all this. And if you are already familiar, do let me know. Maybe I'm making it like too simple or too complex. If you already have knowledge, that's Okay, so I'm just querying this table. So there is a Snowflake sample database. So whenever we signed up, right, in all Snowflake databases, this is a sample data they are sharing. So this sample database has, like, some huge big tables, 1 terabyte, 10 terabytes. From KBs to TBs, we have data. So we can use this sample data for performance testing and all. But for now, I'm just querying this table. Okay, you can see the query is executing, right? Query is executing and I'm seeing the results. But in backend, what happens is whenever we execute this query in Snowflake, right? When I run this query, what happens? So whenever I click that run button, the query will go to the first layer. Okay. So in the first layer, we have this optimizer, right? What optimizer will do? So this optimizer will prepare a query execution plan. So it will prepare query execution plan. Query execution plan. So then what happens? This will prepare query execution plan and it will submit that plan to the compute layer. Okay. So this computer layer, here the computers will be there, like servers, same like our laptops and desktops. Here multiple computers are there. Okay. So it's 1 hour session. We'll just to understand this layer, it will take like 1 hour. So tomorrow's session is all about, we'll deep dive into virtual warehouse. Okay. So these computers are always in the turned off, like, they're not active. Same like, you have your laptop, it is in shutdown state. Okay. So if you want to use your computer, what you will do, you will start, right? Windows will start. Same way, these computers are not in active state. Whenever it receives the execution plan, the systems will become active. When it will become active, the billing will start because Snowflake is per second billing. So if you use for 1 minute 20 seconds, they'll bill you only for 1 minute and 20 seconds, not more than that. So yeah, the systems will be on, the billing will start. But does it have the required data? The computer is here, but data is not there, right? Where is data? Data is in storage layer. Then what the system will do? The systems will connect to the storage layer. So if you want to remember, so for example, this is your laptop. You want to watch some movie, but where are the movies? Let's assume you have your hard disk, external hard disk. Movies are here. So if you want to watch movie, then what you have to do? You have to connect your external hard disk to your laptop. You have to either copy the data, right? For example, like there are two movies. You want to copy those movies and you want to disconnect, right? Same way what this compute layer will do is, compute layer will connect to the storage layer. Here, let's assume I have 1 GB of data. It will download all this 1 GB of data into the compute layer. Okay. Then this computer has a data. What it will do, this is a simple select star. For example, if I have written like sum, min, max, group by, or any condition, it will do that computation. It will do that computation and the results, the output of that query will be submitted back to the cloud service layer. So this is, in this way, Snowflake will process your entire data. Okay. So this is how the Snowflake architecture, like we'll discuss about how it will scale up and scale down and storage, all this in coming classes, but at high level, hope you got some understanding. So one thing, like, they patented this architecture. So they patented, that means if AWS or Azure or for any other company, if they want to copy this architecture, it is not possible because they patented. So what's so different about this architecture? How this is different from Oracle, SQL Server, or any other database? Let's see that. Now that you got the basic understanding, right? Now let's see how this architecture is different from other databases. Okay, so the other, when I say other databases on-prem, like, you can compare with MySQL, Oracle, any other, like Microsoft SQL Server, all these databases. So there are two types of architectures. One is called shared disk architecture and another is called shared nothing architecture. Okay. In shared disk architecture, you can see these are computing racks. Suppose if you have seen this data center, right? There will be compute racks. Let me close. There are multiple tabs open. I'm getting confused. All right, no, just a minute. Okay, can you see this? So what are all this? These are racks, computing racks, right? It's all like the servers will be placed in that server racks, right? All this like these boxes as servers, and all they are connected by wires. It's like if massive big data center, Google, Facebook, they need like hundreds and thousands of computer, right? Because there are like millions of people throughout the globe will access their website. In order to run that, they have to handle huge traffic, right? So they need multiple computers. So all these are like computing racks. So same way in if you take like Instagram database, Facebook, right? I mean, Instagram application also have some database in backend, right? And also Facebook has its own database, because if you write any post, upload pictures, it has to store in database. So we can configure in backend. What happens? All these are computing racks. Okay. Only compute like CPU, RAM. But in the shared disk architecture, they have a single storage. Let's assume this is a hard disk. All these computers are connected to a single hard disk. Okay. So imagine you have 5 laptops. Again, you will ask me like, okay, why can't like database has hard disk? It has its own hard disk. No, think about like this is one server without a hard disk and all. There are like 4 computers, one single hard disk. All these computers are connected to this hard disk, this external storage. So maybe let's assume this laptop has its own hard disk, but what I'm doing is I bought some 5 terabyte hard disk, and I connected all this, I attached all these computers or servers to this hard disk. Okay. So this is what I'm calling as a shared disk architecture. Then what I'll do? Here I will install Oracle. Here also I will install Oracle, Oracle, Oracle. So there are like 1, 2, 3, 4 Oracles are installed. Software is installed across these 4 computers. Okay. So I'll call it with different names, computers, like servers, and also sometimes like cluster of computers. I'm just referring to CPU, RAM, like just like your laptop. Okay, server. Now, there is one problem. So what happens here? Like few companies, for example, let's assume Amazon or Flipkart, what they did, they bought like multiple servers and they installed Oracle in their multiple servers. But what they're doing is they're just maintaining one storage. There is only one hard disk. Now, as a result, what happens? There is one downside to this approach. So these are like very old architectures. Like, if you go way back, I don't know when RDMS started, maybe in 90s or 80s, I don't know. So uh, this is like a very old style architecture. It's not like anything new. These architectures like implemented very long back. So yeah, in this architecture, there is one limitation. So each and every hard disk has a limitation, which is called like, do you know what is IOPS?
No.
IOPS. Okay. So IOPS stands for input and output operations. Okay. So see, IOPS, input output operations per second, is the standard unit of measure for maximum number of reads and write to non-contiguous storage. Yeah, ignore this word, but yeah, to storage locations. So that means if you have your memory card, like, in mobiles, you will use memory card. And also at some point you must have used pen drives or external hard disk, right? All these are called storage devices, right? So each and every storage, for example, like if you go to the Flipkart or any website, okay, Flipkart, something like, I have space. Okay, can you see this? So they mentioned 120 megabytes per second data transfer rate. So what is this? This is what IOPS limitation. This is called IOPS limitation. So why we should worry about this IOPS? Okay. So why it is important is think about like a scenario. So the this particular hard disk limitation is 1 GB per second. Let's assume 1 GBps, gigabytes per second. That means any given second, you can write 1 GB of data into this hard disk and you can read 1 gigabytes of data from this hard disk. Okay. So what happens? Let's assume this computer is writing some data. Okay. And this computer is reading the data. This computer is writing the data. So simultaneously, it is reading the data, writing the data. But what is the limitation of this hard disk? Any given second, I can store only 1 GB of data, or I can read 1 GB of data from this hard disk. So if this is writing 1 GB and this is querying like another GB of data, what will happen? It won't respond, right? So for example, your laptop, this is your laptop hard disk. If you copy one movie, it will show like, in 10 minutes, it will get complete. If you add one more, what will happen? The time will increase to 20. And if you copy like 50 movies at a time, what will happen? It will show like 24 hours remaining or 18 hours or whatever time it will show. Why? So it will predict the time based on that limitation. So that is why in this architecture, what happens is if you write too many queries, the database won't respond because it can't retrieve the data from hard disk. So that is the challenge with this architecture because all the systems are connected to one database. And if you query multiple tables, like multiple queries are running at a time, so it will reach the limitation. So what is happening here? This is, we are scaling up the compute. Here, if you notice technically, why we need multiple computers here? Why we need multiple computers? To handle more queries, right? So for example, now I have one system. So what is, there will be some limitation, right? Something like 20 GB and some CPU, like, 6-core CPU. Let's assume like technically you can process around 100 GB of data, maybe max. So I have like more data to process and I want to process multiple queries at the same time. Now what happens? I don't have this compute power, right? My one system cannot handle too many requests. Then what I have to do? I have to purchase a new server. This is also busy. I'm continuously using both. So if you see like few years back when Flipkart or Amazon, they launched in India, Flipkart and Big Billion Day sale, it used to go very beginning, like way back, maybe 5 or like, I don't know when Flipkart launched, like way back, 10 years back, I guess, like Flipkart used to be, the site used to go down. Why? Because the Flipkart web page is here. Too many people are sending the request to this web page. So what is that is nothing but one HTML will be stored here. When this computer receives too many requests, what will happen? The application won't work, right? Suppose if you open like 1 GB of data or 10 GB of data in your laptop, if you keep on opening like, multiple, you are playing video, you are opening Excel spreadsheet, you are downloading something. If you do multiple operations at a time, your system will hang, right? If you open 100 Chrome tabs, what will happen? It will crash, right? Same way, the systems will crash. Oracle won't respond. It is also one software, right? It won't respond. So now in order to increase my capacity, now I have to purchase a new server so that whenever it reaches its limitation, I'll redirect few of the requests to this server. When this is also busy, I have to add new server. So this is nothing but we are scaling up the compute. That means we are adding more compute. We are adding more compute, but we have the centralized storage. Now, in order to avoid this IOPS limitation, because all these systems are connected to this to the same storage. In order to avoid this limitation, industry has come up with a new architecture called shared nothing architecture. Okay. So in shared nothing architecture, what will happen is, so you can see each computer has its own storage. Same like our laptop has its own storage, hard disk. So each and every computer has its own storage. Okay. And what is happening here? We are scaling up the compute, but at the same time, our storage is also getting scaled up. As a result, what happens? All the systems are interconnected, but still what happens is each and every server has its own storage. So if this system is writing and this system is reading, this system will read from here, this system will write. So that IO limitation can be managed because we have, if each computer, it has like its own hard disk, right? So we are avoiding this IOPS limitation here. Now, coming to the Snowflake, it is called multi-clustered shared data architecture. So Snowflake architecture is hybrid of traditional shared disk architecture and shared nothing architecture. So if you notice here, all these three are different computers. Okay, because Snowflake is running on cloud, they will see, for example, think about like you are using, for example, you will use Instagram, right? So Instagram is owned by Facebook. So let's say this Facebook company, they don't have any data centers. Okay, they created this Instagram, they coded this Instagram application, they kept it in Play Store, but they don't have any servers. Facebook doesn't have any servers. Then how can this app will work? It needs some compute, and also whenever you post any pictures and all, it has to store in database. Then what Facebook will do? Facebook will go to AWS or Azure or Google, GCP. These are like cloud services, right? Hope you know. Are you aware of all these services or no? You know what
Yes.
is? Yes, right? Okay. Shri, I think you already have Hadoop knowledge, right?
Yes, a bit actually. It's been a time, so
Okay. Okay. But you
Spark
know,
and Scala. Yes, yes, I have idea.
okay. I'm just checking like if this making sense or like
Yes,
if you,
yes, yeah. I recollect all this. I'm just
yeah.
yeah.
Okay. All right. Yeah. So now this Instagram, right? It needs compute. But this Facebook company, they don't have a computers. Then what they will do? They'll go to the AWS. They'll say, okay, I have this Instagram. I need like maybe Oracle database. I want to run Oracle database. And also I want to store some millions and trillions of video. I need like some petabytes of data storage. Then AWS will say, okay, you can use S3 service. So S3, same like Google Drive. So for example, Google has like Google Drive, right? So for example, if I open like Google, so what Google is offering here, Google has Google Search, Google Maps, YouTube, and Gmail. All these are like Google services, right? Google Notes and everything. Same way, AWS has 300 plus services. For example, if you want to store 5 GB of data in Google, where do you store? Definitely we'll use Google Drive, right? Google Drive. Same way in S3 also, in AWS also, we have a service called S3. So it is a storage service. Same like in Google, we have a Google Drive, or like Microsoft has OneDrive. Same like AWS has this service called S3 for storing the data. So then what this Instagram will do, it will use S3 for storing the files. Maybe I'm talking about Snowflake. Snowflake company, they developed this software. See, database is nothing but one software, right? You can install, you can download MySQL and you can install your laptop, right? That is the end of the day. Database is also nothing but it's a piece of software, right? Snowflake is also software. They developed this software, but what they decided, the Snowflake company, they don't want to take headache of purchasing the servers, installing the Snowflake there. They don't want to take that headache. Then what they did, Snowflake has a tie-up with AWS, Azure, and GCP. So if you remember, when we are signing up for trial account, they're asking like whether you want to go with AWS, Azure, or GCP. For example, in India, we have AWS data center in Mumbai, and Azure has a data center in Hyderabad, I guess, but yeah, or Pune, yeah, but AWS has data center in Mumbai. So, but GCP, Google doesn't have any data center in India. That means if you go with AWS Mumbai, what happens? Any data you upload into Snowflake, that data physically stores in AWS Mumbai data center. Okay. So yeah, but yeah, here all these three are running on different cloud services. So if you compare here, what happens like my database, if you, for example, if you install MySQL in your laptop, so that hard disk, CPU, RAM, everything is there in one system, right? Everything is there in one system. But now if you see this in cloud, this is running on one service. This is like uh, uh, data storage is nothing but AWS S3. These are nothing but EC2. All these three are disconnected. But whenever there is a requirement, they will connect with each other. For example, if you're running a query, it needs a compute. So cloud service layer will connect to the warehouse. For what? To compute. But where is data? I don't have data here. Then what this warehouse will do? Warehouse will reach to the storage, get the required data, do that processing, right? So all these services are not connected. If you notice, if you all these are like in different systems. So for example, storage is in one laptop. Let's say uh, I have five laptops in my home. In one laptop, my data is stored. Okay, my data is stored. So SQL Server is installed in another laptop, second laptop, and third laptop I have some other. So these three are disconnected, but whenever there is a requirement, they will connect each other over network. Then it will do that processing and all. Yeah, why this is important? So here, why we need more computers to process more data. So same way, what Snowflake will do is it will scale up. It will scale up independently. So yeah, I'll come to what is scaling up, but yeah. So Snowflake architecture is hybrid of traditional shared disk architecture and shared name. The what I'm saying is Snowflake architecture, this is combination of this both of this architecture. How come it can be both? Let's see that. Similar to shared disk architecture, Snowflake uses central data repository for persistent data that is accessible from all computer nodes in the data warehouse. So in this architecture, we have multiple computers. Multiple computers have storage is connected to all the computers, right? In the same notice here, Snowflake also have multiple computers, servers. So data is stored same like how the data is stored here. The data, whenever there is a requirement, all these nodes can storage. So that is why the shade nothing are MPP, parallel processing frameworks like Hadoop, right? Uh, all these are called MPP based systems, databases. Stands for massive parallel. Can have petabytes of data. For example, you are using SQL Server. You cannot write like queries on petabyte of data. Work if you are writing based system. For example, Google BigQuery. Systems are processing. Yeah, similar to shared nothing queries you Like here, computer is not able to park. Okay, don't. What it will do is it, for example, this is, it will distribute, it will break, will get process here, second process and parallelly across multiple systems. That is called MPP, massive parallel processing. This approach simplicity of the problem with scaling up, right? So for example, you want to scale up. So you have one laptop. So you compute laptop be without hard disk, you don't have a computer. But Snowflake doesn't have those headaches. Scale, you are scaling up, scale up. So that is the issue. And the other DBs. But in Snow, my storage, I can add, I'm scaling up the compute, not scaling up my storage. But my storage, this why they patented this of both, and they designed the compute is independent of storage. This is independent of. Any question?
It's easy to scale, but in shared of both, right?
Scaling up the storage is not getting. Here, what is happening? We are
Mm-hmm.
Snowflake can, whenever it is required. So, for example, you are writing. That means it needs more compute. This layer will scale up. Many systems to accommodate that. Right? Whenever sudden, let's say you want to load. When you want to load, record this computer. What it will do, the moment storage will independent to each other. But see, these are dependent, right? This is hard disk. Same. If you want to scale up, database when your laptop is in. Okay.
No.
Use my compute. So basically, right? So sorry, take this, just ignore. This is a copying up the storage. That's why it is of both shared disk are
That slide. Here the limitation is, yeah, right? The IOPS that is been overcome.
Yes.
The
Nothing.
limit
Right.
input output operations. What is the have the one data store, whereas that limit parallel, right? If we have server, the there is a chance of duplication or
Yeah, this architecture, you will simply take one backup because I need to take back versus multi, right? So there won't be any duplicate. This node fails. Picture there both nodes. Internal. This is like it's not.
the limitation will be okay.
Mm.
Saying the Snowflake, it's like a because of the independent.
Last bit.
Okay,
No.
I'm just trying to understand the part, right? Then and then we have the cloud service. So you will cover in the there. So
Right.
how maintaining in Snow, it's running there again. So
Yes.
that's yes. Okay, good. I'm good now.
Okay. All right. So standard actual private Snowflake. Standard is okay. One important. If we are talking
One more uh, like it
right,
for that.
use S3, but we no need to. So, for example, worried, right? Will internal to
Based on the server data storage with that.
this is
Immunity.
just a
Oh.
storage layer.
So everywhere S3 only, like because we right.
If you select Azure, then it will use
Okay.
selected. So I selected AWS when I'm AWS S3, but then it will use Azure like Google Cloud.
Okay. Yeah.
Just a
platform as while signing up, so we GCP into the in the
8%.
snow anything.
We don't select any of manage. When you load internally, it will store. Yeah, to answer your it is that, but mostly 98% it is same across all the cloud environments.
Yeah.
So
Snowflake is time.
yeah, internally they'll
Have a data.
no. See, they have the think about like they are using that account whichever data about like in such a way. Instagram company to store whatever pictures about storage. You can upload so gallery, you'll click have interference. Upload, they'll take the thing will be handled Snowflake. Same way configuration. We have our tables upload as it uses its this account to store the data. Everything will be taken care by them. All we right? Like it's in upload data from S. Also, there should be some more. Okay, 630 option. I'll cover this later at this. But yeah, I just want to say cloud, but yeah, we no need to worry about cloud credentials. All and but in backend that comes
Okay.
in there when I so for now cloud in the backend we are okay. I'm like at You guys okay at the take only from Monday to if you are free, like I can take on weekend also.
Tomorrow I am available.
I'll create a group. I'm allowed. I'll contact. So I need to let you know by if it is not on Monday for Snowflake trial accounts. You need to sign up for AWS free. So video and sign. Ask for credit card under in a single room. Create a new any YouTube video. Just follow the instructions. AWS Snowflake trial accounts along with AWS trial accounts.
Sure.
Yeah, thank you guys. I need to rush. See you.